Hi everybody, welcome back. All right, so today we're going to talk about our third property of logarithms. It's called the power property, okay? So first we're going to talk about, as we have been for each of these sections, we're just going to talk about some vocabulary so that we have a clear understanding of the terms that we're talking about. So the first thing we want to talk about is just, what does this word power mean? Okay, you know, it's strong, right? Power. So in mathematics, when we talk about having a power, that's actually another word for an exponent, okay? Because exponents are powerful, okay? That means that they affect a number very significantly, even when they're small. So, for example, if you take some number like 4 and you square it, that equals 16. That is way more powerful, significantly more powerful, than if we took 4 and we multiplied it by 2. That would only get us 8, right? So that's not, just so we're clear, that's not a power. But just to give you an idea, 8, you know, that's a much smaller number than 16. So that's why we call them powers, is because they affect numbers more significantly. I think if you have your powerful book, that might be worth getting out right now. You know, just to give you a heads up, you know, a power or an exponent, that's when you take some value to some exponent. So let's say you had the number 5 here. Whatever number's up in this little spot, this little exponent, that would be considered your power, okay? So we're going to be looking at some powers today. And to do that, again, if you haven't noticed, I have my Desmos calculator over here because, as I mentioned to you, if you don't have a calculator currently, it might be in your best interest to just use the calculator from Desmos, okay? And I'm also going to be using my typing feature here just to make some of this typing a little bit easier for some of our numbers. So, without further ado, we're going to do some entering of some logs. I'm going to enter these logs that are on the left-hand side. So you can type these in your calculator, type them on Desmos, whatever you want to do, and we're going to round them to 3 decimal places. So it looks like the log of 4 is 0.602, all right? And it looks like the log, here, let me make these at least some sort of a color, okay? We'll go with purple. So let's see. It looks like the log of 8 is 0.903. And it looks like the log of 9 is 0.954. Okay, so first 3 decimal points. That's all we're going to be rounding to right now. Okay, so those are the log of 4, the log of 8, and the log of 9. Those are what they equal. Okay, and now let's try these on the right-hand side. So if I do 2, and if I start typing log, again, it's going to do 2 times the log of 2. You can include the parentheses or not. It's totally up to you. It looks like this log is 0.602. What if I take the log of 2 and I multiply it by 3? So I do 3 log 2 instead. That is going to be 0.903. And what if I take 2 and I multiply that by the log of 3 instead? That's going to be 0.954. All right. Let's take a look at what's going on here. Once again, I've been doing these examples a little bit in the hopes that, you know, you guys will start to notice something just while I'm kind of working on this math here. And hopefully, my hope, I really, really hope this, is that you notice that A and B are equal. Which parts match? A and B match. And C and D, they also match. They're equal. And what about E and F? Those are equal also. Now, why would that work? Why would that make sense? Well, let's look at the numbers, okay? 4 inside the parentheses. that's the same thing as 2 squared. 8, that's the same thing as 2 to the 3rd power. And 9, well, 9's 3 times 3, so that's 3 squared. So notice that the number that's in front is the power, right? Again, we're coming back to this idea of a power, okay? The exponent that you would use to get that number in the parentheses. So if I was to rewrite, each one of these problems, I would say, the log 4, that's the same thing as the log of 2 squared, but then I can take that exponent and I can put it out in front. And so it's like it's a little coefficient out in front. So here I've got the log of 8, okay? 8 is really 2 to the 3rd power. So I can really write that as 3 times the log of 2. Again, the 3, that power. So I'm going to make a little note. The power becomes the coefficient. I hope that that's helpful to write that down. The power turns into the coefficient. So then in this last one, the log of 9, well, 9 is really 3 squared. So then what happens? The 2 gets written out front of the log of 3. So maybe you guys can make a prediction about the log of 27. Maybe we don't even have to get our calculators out. The log of 27, is that going to be the same as the log of 3 logs of 3? Well, let's see. The log of 27, 27 is 3 times 3 times 3, 3 to the 3rd. So yeah, that should be equal to 3 as a coefficient, log 3. Okay. Fun fact about this next one, let's take a look at this. So this is Miss Schwartz's favorite number. The log of 16, why does it have 2 options here? Why is there a J and a K? Well, 16 is 4 squared. 16 is also 2 to the 4th. So the log of 16 could be equal to 4 log 2, or it could be equal to 2 log 4, because you can write the number 16 with 2 different powers. Okay, and this last one, the log of 25, 25 is 5 squared. So that means that's going to be equal to 2 log 5. And now I do want to point out, you could totally take this time to, keep checking on your calculator if you're like not ready to believe me, like log 16 to log 4, you'd notice, oh, those numbers are the same. Is that the same as 4 log 2? Yes, it is. 3 numbers all the same in a row. Log of 25 is this 1.398 number. 2 logs of 5 is that exact same number. Okay, so you can certainly do that, but hopefully you're starting to see the pattern with the numbers. Okay, and now with that, I want to write down the general rule for you. Okay, so we aren't going to need our calculator anymore. Okay, so I'm just going to take a quick check and make sure our calculator. Here's the general rule, and again, just like each of the other rules, this works in both directions. Okay, so if you have a log and you can write the number as like something to some power, okay? So this is the base of your logarithm. This is the power. Then you can rewrite that as a times the log of whatever you had in parentheses. Okay. So power becomes coefficient. Becomes a coefficient, okay? And that works in both directions, okay? What does that mean? That means if you have a coefficient, so you have something like the right-hand side, you can rewrite the number like it is on the left-hand side. So now I want you to take 5 minutes longer if you need to, and I want you to try this check for understanding, okay? There are 10 problems here, and I want you to see how you do on them, okay? So pause the video, wait, take some time to try these problems out, and then come back and check your answers, okay? So come back and check. Hey there, all right, so anything that's on the line in any one of these problems is the final answer, and anything below it is some side work that maybe you would have done to get to your answer, or maybe work you would have done in your head. Okay, so I'm going to kind of run through these quickly because there's still 4 more to talk about below this. So we use the power product property here first. So 6 times 3 gets us 18, so the log of 18. Here we use the power property talked about in today's video. So we change 5 to an exponent, and then that turns into 2 to the 5th, which is 32. We use the quotient rule in number 3, so we get 6 divided by 5 inside the parentheses. In number 4, we have to combine today's rule where we take the 4 and we turn it into an exponent. And then we divide our values because we use the quotient when we subtract. So 2 to the 4th is 16 divided, since it's minus, divided by 5. Very similar deal here in number 5. This 6 becomes an exponent since it's the quotient of y. And then we get x divided by y to the 6th. And then lastly, this example over here is basically the same problem as number 5, only it's all numbers. So we take 2 to the and make it a power, so 12 squared is 144. And so we have 7 divided by 144 inside the parentheses. All right, folks, here are your last 4 answers for these practice problems. So you've got the log m to the 4th times w to the 3rd. You also have the log of x squared times y cubed divided by z to the 4th. You're dividing by the z because it's being subtracted. Then you have h to the 7th divided by p to the 7th, again because there's subtraction. And then this last one, you have the log of a times l times g, right, because those are added, divided by 2. So you've got the log of alg divided by 2. Get it? Algebra 2 is in that problem. All right, so a couple of other things if you want to think about, how to use your properties most successfully. Try to think about if you're condensing. That's what that was just called above. You want to start with your powers, okay? You want to rewrite your powers, and then from there, finish things off. Otherwise, you can kind of do your addition and your subtraction at the same time, as long as you keep track of which part of the fraction they need to go in. All right? Thank you so much for listening. Have a great rest of your day. Bye.